For part B, we have definite integral from 4 to 9. Okay, and the function is 2 plus square root t over t. Recall the antiderivative. We don't have the product rule, the quotient rule as the derivative rules. What you have to do is just to break it down or separate them into two individual fractions and treat it term by term. Most rules that we use is the power rule. And sometimes we see the sign, the trig function, sometimes we see exponential, something like that. And for this one, we have the numerator as the two terms, denominator one term. Since both of them share the same denominator, we write it as two fractions. The first is 2 over t. The second is square root t over t with respect to t. Some of you still have to be careful with adjusting the power. And what we have to do next, we see what we can do for the first term. Can we simplify more? This one we cannot simplify anymore. The best thing we can do is just write it as 2 multiplied by 1 over t to see the constant multiple, what function that we have to work on next. Okay, I'm going to separate as two definite integral, but you don't really have to. You can treat it as one combined integral just for our convenience and easier to manage. And the second part, the integral from 4 to 9, square root t over t. Recall the integral of t to the power n, or the common variable that we use x with respect to x, is x to the n plus 1 divided by m plus 1 and m plus c. We have to write it as the power, not the reciprocal, not the 1 over t to what power. So adjust this as we have t square root t as t to the power 1/2, right? Divided by t to the first. So to write it as t to what power, you just have to apply the property of the algebra that you adjust the power here as 1/2 minus 1 and becomes t to the negative 1/2. So the second integral, the integrand is t to the negative 1/2, and then with respect to t. Okay, both of them are in the clean form. Next, we're gonna have to think about what rule that we apply to each one. Definitely, the second one we use the power form that I set it aside here that we already used in the previous example. Since for the second one here, if we take care of that first, so t to the 1/2, you're gonna add power one more, and whatever you have, which is supposed to be 1/2, right? So you're gonna divide by the result of the sum of the power there. So t to the n plus 1 divided by n plus 1. That means you divide it by 1/2. How about the first term? You have the constant multiple 2. Think about what function that its derivative is 1 over that term. Anyone could tell me derivative with respect to x of what function that the result is 1 over x? What function that you could think of that its derivative is the reciprocal of that term? Because you have to think backwards, right? What function that its derivative is 1 over x?
It is not x squared, but that's a, sometimes I get tricked by that way. It's a natural log, really.
Yes, it is natural log. Yes, thank you. So you can again you can have the rule, the set of the rules like handy, just in case that you want to make sure you apply the right one. So the derivative of the natural log is 1 over x. Okay, so that is the exception for the power rule, because in the case that the power is -1, like the reciprocal form here, we cannot use the antiderivative of the power rule, because if n is -1, -1 plus 1, what do we get? We get 0, but we cannot divide by 0. That is the exception. So we have to go to the antiderivative of 1 over x with respect to x that returns the natural log of the x plus c. Okay, so the first integral here, you will get the two times the natural log, supposed to be absolute value of the t, just to protect from using the number that zero or lower or the negative number. We cannot because the domain of the natural log is t greater than zero. Okay, for this case, upper limit, I'm done. We are done finding the antiderivative. Okay, so the next part we're gonna evaluate. This is the variable t. I'm gonna remind myself wherever I see t, I replace with the 4 for the lower limit. I replace t with the 9 for the upper limit. And next, we can just compute the number. The first one, you replace t with the 9. The second time, you replace t with the value 4. Okay, so the first group, wherever you see t, you replace with a 9. It's going to be 2 times natural log 9. Absolute value can be omitted because 9 and 4, they are positive number for this problem. And then, okay, that's the first one. The second term, since it divided by 1/2, it's the same as multiplied by the reciprocal, which is 2. I'm going to put the note on the side here. So t to the power 1/2 divided by 1/2 is 2 multiplied by t to the 1/2. What is t to the 1/2 in our convenient way? It's square root of t. So the second term, instead of writing as a power 1/2, I will write it as square root of the t. Okay, and square root t is 9 for this time. That's the first group from using the upper limit. The second group, we're going to use the lower limit. So 2 times the natural log, the t will be 4. And the second term is 2 times square root of 4. And clean up one more time. Square root 9 is 3. Square root 4 is 2. Put them all together again. Now we have 2 times natural log 9 plus 6 because 2 times 3 minus 2 times natural log 4. And then negative distribute to both terms, so it becomes negative. So 2 times 2, that's 4. We see 6 and we see negative 4. Simplify one more round to get 2 times natural log 9 minus 2 times natural log 4 and then plus 2 as the final result.